Okay, I think the audio on that first video was not very good, so I'm trying to do it differently on this one, hopefully to alleviate some of that clicking sound. So sorry, you got to bear through it on the first one because the video's already made, but hopefully this will sound better on this second one. So on this section of the notes, we are going through and we are really continuing to find similar triangles. The only difference is now you might have any of those theorems or those, ways of proving similarity at the same time. And so what becomes more challenging about this is keeping it all straight, first off, and then being able to tell when you're using which. And so here's my trick for that. One, you got to remember what we do with sides and what we do with angles. And I like to just write this down. So again, side lengths have to be proportional. That means if you are looking at side lengths, That means if you are looking at side lengths, you are doing proportions. Angles have to be congruent. So that's one thing you need to keep track of. If you are comparing side lengths, you're looking for them to be proportional. If you are looking at angles, you are looking for them to be congruent. The other thing that I personally like to do is I just like to label what I have on these diagrams. And I like to do that with S's and A's. So for example, on the first one, all I want to write out right now is that I know something about a side, I know something about an angle, and I know something about another side. This might seem difficult, but all you're looking at is, do I have a measurement outside the triangle, or do I know something inside the triangle? And so as I look at my next triangle, I know something about a side, something about an angle, something about a side. So the odds that I'm going to try to use side, angle, side on this one are pretty good because that's the information that I have for that triangle. All right, so again, that will take a little bit more math in a second, but labeling the triangles is something we can do right off the bat. Number two, I only know about 3 sides, and I only know about 3 sides. I don't know anything about the angles in that, so I'm probably going to try to do side, side, side on example number 2. The next one, it looks to me like I know about 1 angle for sure in, that first triangle. Oh, and there's another one. Okay, and then I have another angle in the second triangle, and I think I'm going to have some vertical angles going on. So I'm guessing that I'm probably going to do angle, angle, angle for number 3. Because again, all I know about is angles. On number 4, I have side measurements for the small triangle. Oh, I have all 3 actually. And then I have side measurements for the big triangle. So I'm guessing I'm going to do side, side, side on that one. Kind of see how I'm going through and doing this? So on example number 5, I know these both have an angle in common because they share angle H. I have parallel lines, so I'm probably going to be able to know that these 2 are congruent. That's enough right there to do angle, angle, angle. On number 6, I know all of the side lengths. So I'm probably going to do side, side, side. You see how I'm doing this? On number 7, I have a vertical angle. I have side measurements. So that's probably going to be an SAS example because I have some of each. And then on number 8, I only know about angle measurements. So again, that is like step 1. And if you want to do that for, an entire homework worksheet, which your homework is mostly similar to this page, then that's what you would do. Okay, go through and label, do you know angles or sides? Because that is the first thing you have to figure out. Now, one thing that you also want to remember is when you're doing angle, angle, angle similarity, you actually only have to find 2 angles that are congruent. So then I like to go through and I like to say, okay, well, what would I actually need to prove if I was using this type of similarity? So on number 1, I'm going to have a side and then an angle and then a side. If I have 2 of those sides that are proportional and one of those angles that is congruent, we'd be good to go. Number 2 would be side, side, side. I only know about side lengths, so I'm going to be checking all of those proportions, making sure they match up. Number 3 would be an angle, angle, angle situation. But again, you only have to check 2 angles. And once you've checked 2 angles, if they match up, you're good to go. Number 4, side, side, side. We would be checking 3 proportions. Okay, so again, this is one of those work smarter, not harder situations. What do you need to use that type of similarity? Can you make it easy for yourself? So on number 5, I would need 2 angles. Number 6, I would need 3 sides, all being proportional. Number 7, I need side, angle, side. And remember, the angle has to be between the 2 sides. That might be a hint on number 7. And then on number 8, again, I would just need 2 angles. All right, so that's kind of a way of preparing your worksheet before we get started on the rest of it. Now all you're going to do is you're actually going to check each of these letters. So I want to compare the side lengths first. So let's compare the small side on one to the small side on the other. I would have 3/9. That reduces to 1/3. Okay, cool. So we're looking for all of our side measurements to have that ratio of 1/3. I know that angle F is congruent to angle T. So there's the angle that I need. And then I can compare the last angles, the bigger side to the other side. So I did 3 to 9, so I would do 5 to 15. That also reduces to 1/3. So we can use our little therefore. If you missed that, you can use it. Triangle EFS is similar to triangle. And again, you want to remember I did the orange side, the congruent angle, and then the green side. So I got to do that on this one. Orange side, the congruent angle, and then the green side. RTS. All right, number 2. We are comparing all the sides. So here's where I want to do small, medium, and large. Compare the small sides, see what you get. Compare the medium sides, see what you get. Compare the large sides, see what you get. It doesn't matter which one's new and which one's old, as long as you always do the same proportion. Okay, so you always have to put these over these, or you can always put these over these, either way. So I'm going to do new over old because that's how I like to do it, as we all know. So 20/28, we're going to check that. 25/35, we got to check that. 16/22, we got to check that. So if all of those are proportional, then we can say that we have similar triangles. So I have 0.714. 0.714, 0.727. No, they do not all match. So that is a situation where it's not similar. If they were similar, it would have been by side, 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 but they're not. I guess I should write here too, by the similarity statement, since they're all mixed up, go ahead and write the similarity statement you would use. So you would say those triangles are similar by SAS, or those triangles are similar by side, 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 by angle, angle, angle. Again, the angle, angle, angle one is a little different because you actually only need 2 angles. If 2 angles are congruent, the third one's also congruent, so you don't technically have to check it. So all I have to see is if I have angles that are congruent. The quickest one is that vertical angle in the middle. So angle ABE is congruent to angle CBD. Okay, so that's one that we have. And then the other one, I have 53 and 85. So I know that those don't match up. Let's see, using 180 minus the angles that we know, if we have a congruent angle that is just kind of disguised right now. So when I did that subtraction, I actually ended up with an 85-degree angle, which I wanted. So we can say angle E is congruent to angle C. I was able to use one letter just because there's no other angle that I could be referring to. And then we can say, therefore, triangle ABE is similar to triangle CBD. Again, matching up angles that go together. E went with, actually, did anybody catch it? This should be backwards. It should be DBC. The reason why is E goes with C, right? So E needed to go with C here. Man, that was almost bad. Hopefully you got it. And that is by angle, angle, angle similarity. My favorite one, SSS. I think these are easier just because you only have to check the proportions. Going back and forth, I think, is a little hard on our brains. So I need to check all the small to large sides. Remember, I don't actually have the full length on the sides of that bigger triangle, so you do want to figure those out. Looks like along the top it's 24 and along the bottom it's 20. So again, we're comparing sides. So I can compare 12 and 16. I can compare 18 and 24. And I can compare 15 and 20. Again, that was the side of the smaller triangle compared to the corresponding side of the larger triangle. So let's check all of those ratios. Looks like I get 0.75. 18 divided by 24 is 0.75. 15 divided by 20 is 0.75. Sweet. So we can say triangle, and again, you know, if I'm going to start at P and then go up to the left and down, I'm going to do that same shape for the bigger triangle. So PXY is similar to triangle PQR. How do I know that? By SSS, because it was side, side, side similarity. All right, keep going. We're doing well. If you want to pause and try to finish this, you're welcome to. Otherwise, stick with me. You're working hard. So this one's actually really nice because I've already labeled what's congruent. So it looks like angle H is congruent to angle H in that first triangle. And then because I have corresponding angles on parallel lines, I have two other angles that are congruent, and I'm going to write those out with 3 letters just because angle C actually has 2 angles that could refer to. So I'm going to do angle HCB is congruent to angle HIG. You only need 2 angles when you're doing angle, 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 which is great. So then we're going straight to the similarity statement. Triangle HCB is similar to triangle HIG by angle, angle, angle similarity. Number 6, we're dealing with sides again, which is kind of nice. Again, you just want to match up, you know, small to big. You will actually realize on this one I have 2 sides that are they match. So, you know, one triangle has 2 sides that are 42. That's an isosceles triangle, if anybody remembers from previous years. But just the same, okay? Check the ratios. 30 over 42. I have that one twice, so we know that's going to match, but I don't know the exact value. It is 0.714. And then I need to check the other side. So 25 over 35. 0.714. So they all match up, and we can write that as a similarity statement. So therefore, triangle, and let's see, it'd be STW is similar to triangle ADE by side, side, side. All right, number 7. I do have angles that are congruent. Angle LNM is congruent to angle, let's see, PNO. But when I'm comparing these two sides, look what happens. I have a situation where I'm spelling out a word we're not allowed to say at school, ASS. Remember, I have to have sides that are on either side of the congruent angle. And so that is not the case right now. I actually don't even have to check it because I need the A to be between the two sides. So not similar. If you did check it, that's fine. I actually don't know if they reduce the same. And they actually don't reduce the same. So that would be another way you would get to the right conclusion. Because, no, they do. They do. They both reduce to 0.625. So you do have to recognize that the sides need to be on either side of that angle. And then the last one, I have angle Z is congruent to angle G. I know that because they're both right angles. And then it doesn't appear right now like I have two angles that are congruent. But again, you do want to find missing angles just to make sure. So I'll find angle H, 180 minus 34 minus 90. See what I get on that one. It's 56 degrees. So that actually is not going to go with that 61-degree angle. So I don't have any more, and I would just say not similar. Thank you so much for watching these videos. I really appreciate it. If you guys have questions, we can totally review all of this next week. And I hope you guys are good for the sub and have a really good weekend.